dear students, I am Dr. Shikha Pandey, Associate Professor from Institute of Aeronautical Engineering. Today in this lecture series of this solid waste subject, I will discuss about the leachate treatment. Previously, I have discussed about the leachate and what is the meaning of leachate and from where this leachate has been generated. So, as we have already discussed that the landfill, all solid waste which will be left over in the city and that cannot be disposed or that will be leftover material can be disposed out on the landfill. So, from landfill, what happened during the rainy season or because of the anaerobic condition inside the landfill sites, liquid percolation will be started. So that liquid percolation will enters into the groundwater and that liquid is called as leachate. Liquid is called as leachate. So liquid percolation will be there. So leachate can be defined as any contaminated liquid, any liquid which will be contaminated. See, if anaerobic condition will be there inside the landfill, or sometimes what happen from rainwater, the water will be collected to the landfill and in the cell, small cell will be there onto the waste. So when the water will be enters the landfill, then what happen? It starts leaching. It starts leaching. So on the solid waste, many type of waste will be there. So that water will be mixed up with some toxic substances, with some toxic things. So that can be leached out into the water and that water can sometimes enters to the groundwater or sometimes it will be enters to the subsurface areas also. So leachate can be defined as the contaminated liquid will be there. So in the wastewater in the solid waste, it will be dispersed over the landfill. It will be dispersed over the landfill, solid waste will be there. So when rainwater is coming, so that rainwater will percolates into the solid waste and that enters to the groundwater. That enters to the groundwater. This is called as that liquid is generated from water percolating through a solid waste disposal site and it will be accumulating the contaminants and moving into the subsurface area. It will accumulate many contaminants because the waste is that will be spread on the landfill is from many areas. It will be from many infectious waste will be there. So they will having a contaminants of many things. As in the previous classes, I have discussed about the composition of leachate. Like it will be some ammonia will be there, COD will be very high, BOD is very high, and toxic metal is also there with the leachate. So that's why this leachate is a very dangerous substance. So its treatment is very much required. And leachate is a liquid that drains or leaches from the landfill. Leachate will be drains or leach out to the landfill and it will be varied widely. It will be very widely in the composition regarding with the age of the landfill, regarding with the age of landfills and type of waste which it contains. Obviously, the leachate quantity and leachate amount and leachate quality will depends upon which type of waste is disposed of to the landfill and what is the composition of the waste. If more toxic waste will be there, then the leachate will be more toxic. And the type of waste, so it will be usually contain dissolved solid and suspended material. Obviously, TDS of the leachate is also very high. When we talk about TDS is also very high, like that ammonia concentration is also very high. So everything, all the contaminants that is present on the leachate is very high and it is mainly a liquid. It will be drains or leaches from the landfill. So now we'll discuss about what are the landfill liners, which liners is used on the landfill so that they will filter the leachate and they will not allow the leachate to enters to the groundwater or to goes to the subsurface areas. So it is generally used to control the leachate, to control or to reduce the leachate. So first is the geotextile will be there. Geotextile means geological textile. As the main name suggests that it is a geological textile. So the thin synthetic material is there. That material can be used to minimize the intermixing of the soil and sand or gravel layers. So this type of textile, this geotextile will be put into the bottom of the landfill so that the leachate will not be escaped from the solid waste and it cannot be enters to the groundwater or it cannot enters to the subsurface water. And it is basically this geotextile is a very thin material and it can be mixed with the soil, sand or sometimes gravel also. Next category is the geonet. Geonet is, it is like a geotextile together with a geotextile. With geotextile, geonet will be there. And geotextile is the drainage layer to convey leachate to the leachate collection system. Geonet will be the is like the drainage layer and it convey leachate to the leachate collection system. It will take toward the leachates into the leachate collection system. A drainage line will be there. On this drainage line will take the leachate to the leachate collection system. Okay, next is the geomembrane. Geomembrane is a synthetic material that serves as an impervious barrier to the movement of leachate and landfill gas. So, geomembrane is called as synthetic material that can be served as an impervious barrier for the movement of leachates and landfill gas. So, you can see that three type of liner we have discussed. That liner can be used to control the leachate. So, first one is the geotextile, then geonet and geomembrane. All are some materials, all are kind of textile that will put within the solid waste to filter or to escape the leachate that cannot enter to the groundwater or sometimes the subsurface water. Sometimes this clay liner will also be there. So clay liner will be a crack due to desiccation and it needs to be ensured that the clay doesn't dry as it is being placed. So you can see this is the clay liner will be there. Clay liner, and this what it is doing, clay liner, and what it is doing, it needs to be ensured that the clay doesn't dry out as it is being placed. So SDPE liners, landfill liners will be there. That liner will fill and desiccate and it need to be ensured that the clay doesn't dry out and it is being placed. So the clay that will be put on the cell of the landfill, that clay cannot be dry out. The clay cannot be dry out. So that should be keep in mind while making the landfill. And this cracks is due to desiccation and it is needs to be ensured and it doesn't dry out when it will be being placed outside. So next is we'll discuss about the treatment of leachate. So how we will treat the leachate. So first we'll discuss about the physico-chemical treatment processes. So in physico-chemical treatment process, here it is the reverse osmosis. Reverse osmosis is nothing but the same RO process. So it is a separation process with two streams, one low polluted permeate streams and one high polluted concentrated stream. So in reverse osmosis, two type of method will be followed, where it is a separation process with two streams, one with very less polluted streams and other with the high polluted streams. In this way, that reverse osmosis means the movement of molecules, the movement of contaminants. So here in leachate, what are the movement of molecules? They are the contaminants only. So basically when we talk about what is the osmosis? Osmosis is nothing but the movement of molecules from high concentration towards the low concentration. This is low concentration to high concentration. So this is the osmosis only, from high to low. But reverse osmosis is like, it will be the movement of molecules from high to low, low to high. That's why reverse word will be there. Osmosis is general the movement of molecules from high concentration to lower concentration. But the same way, when we talk about the reverse osmosis, this is just opposite to this osmosis things. Like it will be a movement of molecules from low to high, from low polluted stream to high polluted stream. Next is the biological pre-treatment is necessary for the leachate circulation. So in many cases of separation of ammonia is poor, which could be improved by the chemical addition. to adjust the pH or by two-step reverse osmosis. So for this reverse osmosis process, pre-treatment will be required. So in case of pre-treatment, the ammonium should be separated because the leachate will be having very high quantity of ammonia. So for the pre-treatment process, this ammonia should be separated. So by separating the ammonia, it will be improved by some chemical addition, and that chemical should be added to the leachate, and that is going to adjust the pH by two-step reverse osmosis process. The pH has been adjusted by using two-step reverse osmosis process. So next is the flocculation and precipitation. Flocculation and precipitation is also a process for the leachate treatment. So flocculation is like mainly done to reduce the organic load. Organic load is basically all organic compounds are there in the leachate. Organic are there. So in organic, what it is humic acid. Humic acid and halogenated organics. Halogenated organics is there. Halogenated organic is there. So halogenated, this humic acid and halogenated organic is constitutes and characterized by the parameter called COD and AOX. COD and AOX of the leachate after the biological treatment. So after the biological treatment, this flocculation process and precipitation process has been done for the leachate treatment, because what happened in the leachate, mostly organic load will be there. So this organic load in terms of what? These chemicals, these acids. First is the humic acid and halogenated organic constituents will be there. So it will be characterized by very high COD and AOX. So these methods are the methods of stabilizing the leachate with adding some coagulant agents. So one coagulant agent will be added to the leachate, and it will be going to make a flux with all the organic loads, and that is added a coagulant. The coagulant will have the capacity, is going to make a chemical reaction, and in that they will make a coagulants. Next is some base and acid will be there. Some base and acid will be there, and that should be corrected with some pH amount, with some pH correction. And then next process is the flocculation. So flocculation will some flocculant will be used. Flocculant is the agents. Flocculants are the agent which will be able to make the flock into the leachates where the organic loads will be high. So in spite of being cheap, this technology is not frequently because of the addition of chloride and sulfate into the leachate effluent. So sometimes for the coagulants, chloride will be used, and for the flocculants, sulfate will be used. So we will add these as a flocculants, but the problem is that when the leachate effluent will be there, when the outside this effluent is coming from the leachate, they will be having some amount of some addition of chloride and sulfates. That's why these methods cannot be used on frequently, because the effluent will again having some contaminants of chlorides and sulfate. So next is the process is the evaporation and drying. So this technique are the separation in a clean water stream and a solid phase which include all pollution material. So this technique is the separation of clean water stream and solid phases which include all pollution material. Normally the solid are pulpy and the condensate vapors that contain volatile compound. It will the solid are pulpy in nature. The solids are pulpy in nature. So what it will do? It will the condensate vapors. It will condensate vapors and that contain volatile compounds. The predominant component in effluent of evaporation plant are volatile. So sometimes chlorinated organics and ammonium with the necessity of addition treatment steps. So the predominant component in the effluent of evaporation plants are volatile in nature. So this volatile will be like some chlorinated organics and ammonia will be there. So this will be a very necessary step of additional treatment steps. Next is the aerobic biological treatment. So aerobic biological treatments means the treatment in the presence of oxygen. So for this one, lagoons will be there. A very big pond of lagoon will be there. That is called as aerated lagoons. So aerated lagoons are the simple leachate treatment system, and its retention time of the leachate is long enough so that many bacteria can develop per unit time as of the number. So this retention time of the leachate is very long enough, and the many bacteria will be able to develop with the time, and the species that are transported out of a lagoons with the effluent, and the maintenance and operation costs are relatively low. So in aerated lagoon, what happened? Aerators are there. You can see these are the aerators. Aerators are there. So these aerator will aerate the solid waste, will aerate the leachate. And in this way, retention time of leachate is very long enough so that it may be bacteria and can develop per unit as a number of species, and that can be transported out of lagoon with some effluent. The maintenance and operation costs are generally very low for this aerated lagoons. Next process is the activated sludge system process. So the detention time in activated sludge plants are shorter than in aerated lagoon because the sludge contents can be controlled to a certain degree, that is several high times than in aerated lagoons. Detention time is reduced by installing a settling tank behind the aeration tanks and recirculating the sludge back into the activated sludge tank with a certain amount of sludge removed out of the system. So activated sludge system will involve some aerators. So what these aerator will do, they will be like they will be aerate the leachate. So due to aeration, the dissolved oxygen of the leachate has been increased, and in this way what happened, the activated sludge plant are generally shorter than the aerated lagoons because of the sludge contents, these activated sludge plants are shorter and smaller, and it can be controlled to a certain degree and in several times higher than in aerated lagoons. So for several times it will be higher than the aerated lagoons. Like that, detention time is reduced. The detention time, the settling time, we can say that the settling time is reduced by installing a settling tank behind the aeration tank and recirculating the sludge back into the activated sludge tank with a certain amount of sludge removed out of the system. So this is called as detention time. It will be reduced. What happened with the detention time? It will be reduced by installing a settling tank behind the aeration tank and recirculating the sludge back into the activated sludge tank, will having a certain amount of sludge that will be removed out of the system. So you can see this is the picture of activated sludge system. Raw water will enter to the aeration tank, and next clarifier and settler will be there. This clarifier will settle the TDS and suspended solid, and next treated water will be coming out. Next, what happened from here was waste and sludge that will again going for the recycled sludge, and then the waste and sludge will be coming from here. This is the outlet to sludge treatment unit, and then it will enter to the sludge treatment unit and wastewater treatment unit. Next is the rotating biological contractors and trickling filter. Rotating biological contractors are the process. These process will differ from the activated sludge process in a way that the bacteria are attracted to material of rotating contractors. So this process is different from the activated sludge process because of the bacteria are attracted to materials of rotating contractors. The air supply takes place naturally. The air supply can take place naturally, and it can consume very low amount of energy. And the temperature effects are lower in rotating biological contractors because they are normally covered. So you can see this is the picture of rotating biological contractors. This process is differ from the activated sludge process, like it is a way that the bacteria are attracted to materials of rotating contractors. Bacteria will be attracted toward these rotating contractors. The air supply will take place naturally. Air supply will take place naturally, and it is going to consume low amount of energy. And the temperature effects are generally very less or lower at the for the rotating biological contractor, because they are normally covered. Next is we'll discuss about the anaerobic biological treatment method. So this anaerobic biological treatment method is a very low energy requirement, because no oxygen has to be supplied. It will not require any type of oxygen. Technical anaerobic process used adequate temperatures and have to be designed right. For example, digesters such as USB based on the suspended growth system. Anaerobic filters and hybrid bed filter based on the attached growth process. So you can see that this is like a anaerobic filter or sometimes hybrid bed filter. So hybrid bed filter, it will be kind of hybrid, like aerobic and anaerobic. Both can be worked. So low energy requirement, because very less oxygen has to be supplied, and technically anaerobic process needs adequate temperature and have to be designed right. Example, digesters such as USB based on the suspended growth system. Anaerobic filters and hybrid bed filters. So based on the attached growth process, this anaerobic filter or hybrid bed filter can be studied. So you can see this is the picturization of this integrated leachate treatment. So leachate will enter. This is the leachate, and whatever some biological treatment will be required. So biological treatment and so means what type of requirement, like adsorption, oxidation, and then flocculation, precipitation, neutralization. So first of all, adsorption process will be there, which is addition of active carbon. Next is the oxidation, like ozone plus ultraviolet radiation. From adsorption, two steps will be there, that is flocculation and precipitation. Neutralization is also there. Oxidation can lead toward the biological treatment. So biological treatments will goes toward the adsorption process, that is called as active carbon. So from leachate, reverse osmosis will be there. So if required, it is a kind of two-step process. So after this reverse osmosis, it will directly goes to the drying condition, or sometime drying condition it comes to the reverse osmosis. Again it will be started. Next is the evaporation. Evaporation will be there. From some drying, evaporation will be there. So all will leads toward the effluent. Effluent is the treated leachate. Treated leachate is act as an effluent. So this is the effluent of how this leachate treatment can work. How these are biological treatment and the physico-chemical treatment will involve biological treatment. Biological treatment and physico-chemical treatment. Treatment will involve for the integrated treatment system. Next is the limiting concentration. So what are the aspect, means what is the negative effect of this leachate treatment plants. So first is the limiting concentration. Low demand of resource and low demand of energy. Low generation of residues, especially hazardous waste. So the residue will be less. Concentration is limited, and the resource demand is also less. Like that, energy demand is also low. Next is the low generation of residues, like especially hazardous waste, and obviously low environmental impact and economical efficient operation. So these are the benefits that is related with the leachate treatment plant. So for leachate treatment plant, concentration should be limiting, but the demand of resources is also low. Demand of energy is also low. Low generation of residues like some hazardous waste. Next is the low environmental impact. Economic efficient operation is there. Next process is the moving bed biofilm reactor. So in the moving bed biofilm reactor, what happen? It will be based on the use of suspended polymers like plastic will be there. So carrier which continuously moves inside the aerobic tank and activated biomass that will grows on its surface. So based on the use of suspended polymers, like plastic carrier will be there. Plastic carrier that will be like continuously moves with the aerobic tank and activated biomass grows on its surface. And next, microorganisms are there. So these microorganisms are stuck to the bed. These microorganisms are stuck to the bed without being washed with the flow, increasing the concentration of microorganisms in the system. So these microorganisms will stuck on the bed. You can see that this is a picture of this moving bed biofilm reactor. It will be based like use of suspended polymers like plastic carrier that continuously moves inside the aerobic tank and active biomass grows on its surface. Microorganisms stuck to the bed without being washed with the flow, increasing the concentration of microorganism in the bed. Next is the membrane bioreactor. Membrane bioreactor is the combination of biological and physical process. So in the membrane bioreactor, what happens? Aerobic bioreactor unit through supplying oxygen leads to COD oxidation. So aerobic bioreactor will be there. Aerobic, they are like supplying oxygen. Supplying oxygen, it will lead toward the COD oxidation and nitrification. COD oxidation and nitrification. And anoxic unit, in the absence of oxygen, it will lead towards the denitrification. Next, what happened? High sludge retention time. It will lead to the growth of nitrifying bacteria that has significant influence on the nitrification process, because in the leachate, ammonia quality is very high. Ammonia is high. That's why this nitrifying bacteria will reduce. Nitrifying bacteria will reduce, and it will reduces the sludge retention time. Next, so membrane reactor, its advantage and disadvantage. Its advantage is that it is having less sludge production and effluents of high quality, high concentration of nitrifying bacteria. And when we talk about the disadvantage, it is having high initial investment and running cost due to the shorter lifespan of membrane and also their needs for maintenance and cleaning. So advantage is like sludge production is very less, and its effluent is having a very high quality and very high concentration of nitrifying bacteria is there. On the other hand, initially it will be required very high investment and running cost because of the shorter lifespan of membranes and also their need for maintenance and cleaning. So the maintenance and cleaning is very costly, and the initial investment and running cost will be like shorter lifespan of membrane. And advantage is like that, very less sludge production, effluents of very high quality, high concentration of nitrifying bacteria. So these are the references of some of the textbook that you can go and you can study in depth if you want to study about these topics, like which method will be used for the treatment of leachates. So now I am concluding my lecture at this point. In this class, I have discussed about the methods that can be used for the treatment of leachate, like aerobic method and anaerobic methods. Which method will be best and what are the technology? We'll discuss in next class about some technology. That technology has been adopted by some big industries so they can treat the leachate. So if you have any query, if you have any question regarding this lecture, you can write in the comment box or you can directly mail me onto my given mail ID. So thank you for this lecture.
Like, share and subscribe. Hit the bell icon for more updates.